Hi, I'm Gage Rovelli, and this is Street Smart's Imaginary Numbers. Now, let's start. What is an imaginary number? Is an imaginary number just a number that I think about, that I imagine? Like I'm imagining the number 2, does that make it an imaginary number? No. The best way to learn about imaginary numbers is to first recall and review over what is a real number. A real number can be broken up into two groups, rational and irrational. The rational side, including terminating decimals like 3.75, and non-terminating reoccurring decimals like 0.66 repeating. The irrational side, including non-terminating, non-repeating decimals, such as pi, 3.14159. Now that we have these real numbers reviewed, let's go over what makes an imaginary number. It's actually an I. That's what shows an imaginary number. No, not the I. It's the letter I, the lowercase letter I, common misconceptions. But the lowercase little I represents the imaginary number. As seen here, I've made a chart of the different powers of I and the different solutions that it gives. As you can see, there is an order. It goes 1, I, -1, I. And this order continues. As you can see, every 4 powers, the solution is the same. If you want to pause the video and look at the work, you are welcome to, but for time's sake, I'm just going to push through and I'm going to let you guys know what the pattern is. Every 4th power it repeats, it goes 1, I, -1, I. This pattern can be used to predict higher exponential values of I. This will really help you in the future for more complex equations, and it continues with this pattern as far as you go down the list. Now, what is I? We know it's not a real number. It's actually known as a non-real number. The definition is basically any number multiplied by itself to get a negative number. This is shown by the most common use of I to the second, which equals -1. This means I times itself equals a negative number, the definition of a non-real number. It's not invisible, but you can't really see it on a number line, and you won't see it commonly, but you will often see it on a graph. The way you see this on a graph is not simply like this. You can't just say, find I. I mean, I guess you could if you do this solution, but I don't think it would be marked correct. What you really need is a complex number. A complex number is shown by a plus bi, the a being the real number and the bi being the imaginary number. If you see this on a test, you should be very happy, because the a corresponds directly to the x and the b corresponds directly to the y in your answers. I always remember this as I is with the y. So, using this equation, we know 3 is the x value and 4 is the y value because it is with the I. So the real number is always the x, and the imaginary number is always the y. So if I'm graphing it right now, I go 3, 4. Same thing with this, -3, 4. It's basically just your point, but it's given to you in your equation if you just know what to look for. Thank you for watching today. I hope that the street taught you a few things about imaginary numbers, and maybe you'll walk away a tad bit more street smart. Thank you.